Hello, class. So today we're going to be calculating density. So to start this off, I'm going to start with two familiar objects, not the marker, a tiny marble and a wooden block. So a lot of the time when you ask someone, will something sink or float? They'll think in their head, well, if it's heavy, it'll sink. And if it's not so heavy or if it's light, then it will float. But I just want to prove that to be wrong because a marble is tiny and not very heavy. And when we put it in water, it sinks. A wooden block, pretty heavy. And if we put it in the water, at least part of it floats, right? Even if I try and push it down, it comes back up. So we can't say heavy things always sink, light things always float, because clearly that's not the case. So we have to come up with something else to let us know that. And in that case, that is going to be density. So if things are really, really dense, they'll tend to sink in water. And if things are not very dense, they'll tend to float in water. So just to give you some information here, we've got a balance which measures mass in grams, and we've got a graduated cylinder which measures volume, or the amount of space something takes up, and that's measured in milliliters. So volume is the amount of space that something takes up. So I have more volume than this jug of oil, right? And this jug of oil has more volume than this corn syrup because it's just talking about the size of things. All right? So in this, we're going to be discovering the density of objects, and it's going to give us a particular number. So density is a formula that uses how heavy something is, or its mass, and then it finds the volume of it, and we find out how much density the object has. So really just density is just a calculation where we take mass and we divide it by volume. Mass divided by volume. Something you should know is that water will almost always, depending on its temperature, but we're going to say water always has a density of 1 gram, that's mass, per milliliter. So 1 gram per milliliter. What does the gram per milliliter mean? It literally just means density, the amount of mass something has versus the amount of volume it takes up. But let's get into some information. So this wooden block is pretty big compared to the 50-gram weight that I have, the large marble, and the small marble. Okay? And we're going to find the density of all these objects. I'm going to do the density of one of these objects, and you're going to do the density of the rest of them. So the volume of the wooden block, I can't stick it in water and get its volume like we do the other objects, but I already measured this. So it's 8 centimeters by 8 centimeters by 5 centimeters. And if you throw those numbers into a calculator, we multiply them together, we're going to get a volume of 320 cubic centimeters, which we're lucky that that transfers to milliliters or milliliters. So it's volume, it's the amount of space something takes up. The mass of the wooden block is 175 grams. And I'm not gonna do any decimals for this. All right, so we have 175 grams and 320 milliliters. To calculate that, we need to do density equals the mass divided by the volume. All right, so that's mass divided by the volume. So if I put that in, 175 grams divided by 320 milliliters. By the way, the calculator does not do units. We're just going to leave the units out of the calculator and we'll put them in at the end. So what I typed in there really was 175 grams, which I can't do the grams in the calculator, but I put it in the formula, right? divided by 320 milliliters. So the grams is our mass. The 320 milliliters is our volume. If we put this in a calculator, first thing I'm going to look at before I do, there's a smaller number, 175, over a bigger number, 320. Whenever we have a smaller number divided by a bigger number, it's going to give us a number less than 1. So this density is 0.54, 0.54 grams per milliliter. Okay, that's the density of the wooden block. Now, like I said, the density of water is 1, and the density of the wood block is less than 1. So that means that the wood block is less dense, and that's exactly why it floats. So now let's look at an object that's more dense than water, and way more dense than water. This is brass. This is a 50-gram weight, so lucky for us, we do not have to find its mass, even though it's as easy as placing on that balance, but it's 50 grams. And right now, it's 50.2 grams, so either the balance is off or something got stuck on here, maybe adding on a little mass. Now, to calculate the volume is a little more complicated for this, all right? So I've got this right here, right? And it's actually filled with water up to 50 milliliters. So it's starting at 50 milliliters. That doesn't have anything to do necessarily with this because it's not in there yet. But since I can't take a ruler to this and measure all these rounded edges and weird corners, I'm gonna stick it into the 50 milliliters of water. And when it goes in there, it's going to raise the water level, right? Because it takes up space, it takes up volume. This measures volume, so the water level changes. When I put that down on a surface, I'm going to get a measurement. It is at 56 milliliters. So if we started with 50 milliliters of water, and then when we put that 50-gram mass in there, it made the water rise 6 milliliters, it brought it up to 56. So let's do a little calculation. If I take away the water, right? The water is the 50 milliliters, and the water and the brass weight is 56. Let's take away that water, and we end up with 6 milliliters. So 6 milliliters. Now, what's the density formula? Density is mass divided by volume. We have a mass of the weight, which is 50 grams, divided by the volume, which is 6 milliliters. So I'm just going to do 50 grams divided by 6 milliliters because we're going to do mass, top, and the bottom is volume divided by the volume. And I'll plug that in the calculator. 50 divided by 6 equals 8.3 repeated. So we'll just say that's going to be 8.33 grams per milliliter. Now, that is the density of the brass. So now let's just double check. If its density is 8 and water's density is 1, that means brass is more dense than water, which is why, hopefully it doesn't break anything, it hits the bottom. And it's way more dense than water, and that's why it went crashing down into the bottom, because it's so much more dense than water. So what I'm going to have you calculate is the large marble and the small marble density. Now, one thing I want to point out is that marbles are both made of the same type of glass. So the material it's made of is really what determines the object's density. So all water is made up of 1 gram per milliliter for its density. So these densities should be the same. So if you get the same answer for both of these, you should be set. All right? So the large marble's mass is 10 grams, and its volume is 5 milliliters. The small marble's mass is 6 grams, and its volume is 3 milliliters. So what I need you to do is use the density formula, which is a mass, right, divided by a volume in order to calculate the density. All right? Hopefully that makes sense.